Hello everybody, welcome back to CTO Demon channel. Today we have another core curriculum talk. Now this is going to be another talk about the retrograde CTO PCI procedure, and it's another very small gap in the procedure. Last time, remember, we had a gap from reverse cut to antegrade wire access. See the video in the link of the description below. But this time is another small gap. Now after you've got antegrade wire access, the rest of the procedure is very similar to normal PCI. It's ballooning, lesion preparation, stenting, imaging, post-dilating, all the usual stuff. But when you finish that, you need to remove the retrograde gear. And this video is going to talk about how to remove the retrograde gear safely. Now, there are certain guiding principles about what we want to achieve when we remove the retrograde gear safely. Number one is we want to, at all times, protect the retrograde channel from the cheese cutting effect of the retrograde wire. When we have an externalized wire, the wire is very long and it travels from one access site through the retrograde guiding catheter, through the donor artery, through the collateral channel, through the CTO vessel, through the antegrade guiding catheter, all the way out. And because it's such a long wire, each part of that wire has some friction with the guiding catheter, with the donor vessel, with the collateral channel. And when you pull on a wire with so much friction, the wire will cheese cut through the channel if there's no protection on the channel. So at all times, we want to have a microcatheter covering the channel when we're putting the wire. That's principle number one. Secondly, when we pull the retrograde gear out, this pulling also has a lot of friction. And so it causes the counter movement of the retrograde guiding catheter deep diving into the left main or into the ostium of the right coronary artery. And this can cause retrograde vessel ostium dissection. So it's very important to prevent this. And there are two main ways of preventing this. Number one is to back out the retrograde guiding. And in the old days, we used to back it out all the way to the ascending aorta, so that no matter how hard you pull, the guiding will not deep seat into the ostium of the donor vessel. The second way is to put a cuss wire on the retrograde guiding into the aortic cuffs, so that the wire will stop the guiding deep seating into the coronary vessel. It's important, if you do this, to make sure that the cuss wire is far out, so that the stiff part of the wire is there to stop the guiding deep going in. And it's also important to keep fluoroscopy on this guiding, because sometimes the force is so strong that even with a cuss wire, the guiding can deep seat into the donor artery ostium. Okay, so number three is we want to have access to both sides of the retrograde channel when we do a contrast checking of the channel to make sure the channel doesn't have a perforation. So we want to be able to quickly get in to both sides of the channel to deliver cause if we do find a perforation. Then there are two more minor principles. Number four is we want to preferably do guiding catheter injection rather than selective injection through microcatheter to check for perforation. Because if we have some small damage, especially in septocollateral channels, if we pressurize it by doing a selective injection, that can cause a small damage to become a hematoma. So especially for septal channels, we want to do guiding injections to check for perforations. Guiding injections is preferable over selective injection. And finally, is that we should always do bilateral injections from both sides, because the channel can perforate from one side that you can't see with an injection from the other side. So finally, is number five is we want to do bilateral injection to make sure of channel integrity. Okay, so these are the principles, and you can actually, in every case, think about these principles and work out a way to remove the retrograde gear, keeping all these safety principles intact. However, of course, in practice, of course, you can then describe the methods that you can use to achieve this. Now, the methods can be divided into three groups of methods. The first is the retrograde microcatheter recross methods. The retrograde microcatheter recross methods. This is the classical traditional method. And this involves using only the retrograde microcatheter. So what we do is, after we finish stenting the whole vessel, we push the retrograde microcatheter all the way back up into the antegrade guiding, and then we start pulling the retrograde wire out. Okay, we pull the retrograde wire back out so that the tip of the retrograde wire is inside the ascending aorta portion of the antegrade guiding. I repeat this. We pull the retrograde wire out until the tip of the retrograde wire is inside the ascending aorta portion of the antegrade guiding. So not all the way out, but inside the guiding. Because when you're still inside the guiding, you can always trap it, and then it's very powerful force to allow you to track the retrograde microcatheter across, and you can push the wire back out and re-externalize. So this ensures that you have control on both sides of the channel when you're checking. At this point, you then back out your retrograde guiding or put a cusp wire in, and you start removing the retrograde microcatheter until the retrograde microcatheter is inside the donor vessel itself and out of the channel. Then you do guiding injections on both sides to check the integrity of the channel. Now, at this point, if you have a perforation, you can easily trap the retrograde wire inside the antegrade guiding and push the retrograde microcatheter back across, re-externalize the wire by pushing it all the way out, and put a microcatheter on the other side. And by backing one microcatheter and pushing the other microcatheter, you can have control of the collateral channel and call and do whatever you need. Okay, so you're in a good position to gain control. Now, after you have checked and if there's no perforation, you need to recross the channel with the microcatheter, because you still have to pull the retrograde wire from the antegrade guiding back down. And that little distance, especially if the CTO vessel is quite tortuous, can cause enough resistance to G-cut the channel. So you want to protect the channel at all times, you remember. So we will push the microcatheter back across the channel, okay? And if we need to, we can anchor to do this. And then we will pull the retrograde wire to the distal part of the CTO vessel. Then again, we back off the retrograde microcatheter, again, by pulling back the retrograde guiding over the cusp wire to protect the donor artery ostium. Then again, we do another injection to make sure there's no perforation, remove the wire, then we do a final check. Okay, so this is the retrograde microcatheter recross method. And this is the traditional method that only requires the retrograde microcatheter. Now, a far more efficient method, and I think probably the more popular method nowadays, is the antegrade microcatheter method. The antegrade microcatheter method is any method that involves using an antegrade microcatheter. So when you finish stenting, you put an antegrade microcatheter onto the externalized wire down the antegrade side until both the antegrade and retrograde microcatheter meet each other. And you put the meeting point in the distal part of the CTO vessel where it's straight, because you don't want to cut anything there. But you don't want the two microcatheters to be kissing each other, because if you pull a wire and the two microcatheters are kissing, sometimes that causes fusion of the two tips of the microcatheter. So you want a little gap, maybe a 2 millimeter or 3 millimeter gap between them, but in a part of the vessel where it's pretty normal and pretty straight. Then you can pull the retrograde wire back until the tip of the retrograde wire is inside the antegrade microcatheter, inside the CTO vessel. Now, then you can back out the retrograde guiding or put a cusp wire and back out the retrograde microcatheter until the microcatheter is outside the channel in the donor vessel. Now, what you have here then is a wire from the retrograde side going through the retrograde microcatheter, through the channel, and inside, tip into, really, remaining inside the antegrade microcatheter. Then you can do bilateral guiding injections, and if the channel is okay, then you can just pull the wire out and do final angiograms. If the wire is not okay, you actually have immediate access with two microcatheters to the channel, because each microcatheter is only a short distance away from the channel. And you can just push the antegrade microcatheter tracking over the retrograde wire into the channel, and you can push the retrograde microcatheter inside the channel, and you can coil both sides. So this is a very good method because you have immediate control and it's less fidgety than the retrograde microcatheter recross methods in terms of coiling the channel. And that's why I think this antegrade microcatheter method is becoming the dominant method. Now there's a subversion of this method, which is instead of doing guiding injections, you can actually push both microcatheters inside the channel, remove the wire, and do selective injections on either side. Of course, the disadvantage, as we mentioned before, you pressurize the channel, so don't do this in septos. But for arterialized channels, epicardial channels, this is an okay method, okay? And if you have perforation, you're already set up for coiling, so that's ideal, okay? So I tend to use this method if I'm fairly convinced I've done a perforation in an epicardial channel and I want to be ready to coil it. Then I'll put both microcatheters inside the channel and pull the last bit of the wire out and then do bilateral injections, selective injections. Okay, the third method is the just remove method. Now, the just remove method is really for cases where you have to stent across the entrance of the channel into the CTO vessel. Now, commonly, this is the LAD CTO. So you've crossed the PD septal channel from the RCA into the LAD, you've wired through the CTO, and you've done reverse card, and you've externalized, and you've pulled the retrograde microcatheter back down into the ostium of the septum. But you realize you have to stent distal LAD, and you stent across the externalized wire. Of course, you don't want to stent across the externalized wire, because if the externalized wire is already full of friction and resistance when you're removing it, if you put a stent and gel part of it, it'll be very hard to remove. So what you want to do is to get antegrade access and remove the retrograde gear before stenting. So the common way to do this is to put a dual lumen catheter onto the antegrade side of the externalized wire, and then with that dual lumen, I'll wire the distal LAD. Now, when you've done that, you're in a position to remove retrograde gear. So what we usually do, okay, is to then back off the dual lumen a little bit so that the ostium of the distal end of the dual lumen catheter is not right at the septum, and we push the retrograde microcatheter up into the LAD so that now both the dual lumen and the tip of the retrograde microcatheter is in the LAD. Then we can remove the retrograde wire as far as the retrograde wire is still inside the antegrade guiding. At this point, we can back the retrograde microcatheter into just the septal channel, okay? So near the LAD, but just inside the septal channel. Then we can pull the retrograde wire until the tip of the wire is just inside the septal channel, okay? Then, of course, we can just stent the LAD. And after stenting, we keep a post-dilatation balloon on the LAD across the septal channel, because this balloon can then blow up to control the retrograde channel if there's a perforation. Then what I usually do is I use the workhorse wire to wire the septal channel, the last bit of the septal channel, back into the stent of the LAD, and then I remove the retrograde microcatheter. Of course, remembering to put a cuss wire or back off the retrograde guiding catheter. When the retrograde microcatheter is outside the channel, then I can do bilateral guiding injections. Now, if I find a perforation at that point, I can just inflate the balloon on the LAD, on the stented area, and that inflated balloon will, one, stop bleeding into the channel, and secondly, it will anchor the retrograde wire. And with the anchor, I can then push the retrograde microcatheter back across, okay? And then, of course, I can remove the wire and I can coil on the LAD side through the retrograde microcatheter, and then I can pull the retrograde microcatheter back towards the PDA side, and I can coil on that side. So I still maintain control over the channel if there's a perforation. And I manage to also check for perforation by guiding injections. So that's the just remove method, and it's most appropriate for when you need to stent across the retrograde channel's entrance into the CTO vessel. So I know this is a bit of a complicated talk, but I think it sort of clarifies this little gap of knowledge, is how to remove the retrograde gear safely and ensure that while we remove the retrograde gear, we keep all these 5 principles intact. So I hope you have a safe time removing your retrograde gear. If you like the channel, do slap the like button. And if you want to subscribe to see new videos, do press the subscribe link here. I'll see you next time. Bye-bye.